Okay, so did you think about it? Do you think about what's going to happen when these things rotate away from each other, where everything's going to end up? I hope so, because if you didn't, then you're going to miss your chance, because I'm going to tell you right now. Okay, so we had our eclipsed conformation. Don't you dare do this to me. We had our eclipsed conformation where we had a methyl group up here, and we had a hydrogen, and then we had, behind it, we had CH2, CH3, and we had a hydrogen, and a hydrogen. And what happens is, of course, these things repel each other. And so we rotate. And we're just going to rotate the front carbon just for simplicity, right? So the back carbon is going to stay the same. So the back carbon is still going to have CH2, CH3 there. It's still going to have a hydrogen over here and a hydrogen over here. But what we're going to do is we're going to rotate this group out of the way. So it's as far away from all the groups on the other one as it can. So it's going to end up kind of in between. Whoops, that's not attached there. It's attached to the middle carbon. There we go. And that's going to rotate the other two. So now what we have is we have these nice kind of intervals. We have an ethyl group up here, an interval, then a methyl group, and then a hydrogen, and then a hydrogen. And every time we go 60 degrees, we run into another group. But the important thing is that these groups don't line up with each other, right? If we look at, instead of having group upon group like this, right, where these two things are running into each other, now we have group and group. And so these no longer, these have a little bit more space to move in, and it's a lot more stable. Right? So this conformation is much better than the one that we started with. So this was eclipsed, and this is unstable. Right? This one is staggered, and it's better. But what happens if we keep rotating? Let's rotate, and I'm not going to we're not going to stop when this methyl group gets to this hydrogen, because that would just be another eclipsed conformation. But let's rotate it 120 degrees so that this methyl group comes all the way down to here. Right? And what we'll get is we'll get the methyl group pointed down, hydrogen here, hydrogen here. The back carbon still remains the same. We're not rotating that at all. And now what you'll notice is that we have our two largest groups, the two groups with the most atoms in them, the most bonds. Because remember, what we're trying to do is we're trying to minimize the repulsion between electrons in sigma bonds. And so in this case, we look, where are the most sigma bonds, right? This is the biggest, or the most sigma bonds. Right? And this one, this is the biggest on carbon B. And this one here is the biggest on carbon A. Right? It has the most sigma bonds. So if we're comparing sigma bonds, we have CH3, which has 3 sigma bonds. We have a hydrogen, which has no sigma bonds, and another hydrogen over here that has no sigma bonds. Right? This is also a staggered conformation, right? All the groups are opposite each other by 60, or offset from each other by 60 degrees. This is the best one though, because in this best one, the largest groups, the biggest groups, are 180 degrees from each other. We call this one anti. So this is anti-staggered, right? And in the anti, the biggest group on carbon A is 180 degrees from the biggest group on carbon B. That's a B. Right. This one over here is not, it's not anti, because the biggest group on carbon A is still next to the carbon B. And so this one is called gauche. Gauche is the French word for awkward. It's like when that person stands just a little bit too close to you and you're like, I need a little bit more space than what you're giving me. That's what gauche is, right? This guy isn't technically like, he's not touching you or like rubbing up against you. That was terrible. pushing against you or touching you or anything, right? Instead, it's just in the neighborhood, just a little bit too close for comfort, right? This is definitely better than this. Staggered is better than eclipsed. Gauche is better than eclipsed. But if you can avoid gauche and get to anti, then that's good. So gauche is when you have your large groups only 60 degrees from each other. Right? And that's, again, better than eclipsed, but not nearly perfect, right? So there's a terrible metaphor. I apologize for that. That's probably not the metaphor I should have chosen. But um, the point is, the important thing of all of this is that the staggered anti-conformation is the most stable. And actually, we've been using the staggered anti-conformation without even really realizing it, because what you'll notice is what this means is that the methyl group and this CH2, CH3 behind it are 180 degrees from each other. And if we draw that out, remember this is carbon A, this is carbon B. Notice that this methyl group is 180 degrees from the direction of this CH2, CH3, right? If you measure the angle between these two are anti to each other. And so when we draw all of our organic molecules kind of in this zigzag fashion, the reason that we draw them, these chains, right? Chains are zigzag because of steric repulsion. Okay? So steric repulsion is the reason that there's zigzag, and what that's doing is it's minimizing the repulsion between the electrons in those sigma bonds. And so when we draw linear chains like this, we always draw them in this zigzag fashion because that's what they actually look like. And the reason that they do that is to avoid these types of interactions, right? They always want to be not just like this with their big groups, but they want to be 180 degrees opposite each other so that these big groups have all kinds of space to kind of move around in and not repel each other. Okay, what that means when we get to cyclic molecules will be the subject of the next video, and we'll finally get to see what is the perfect organic molecule. We'll finally find it. So you didn't even know we were looking, did you? Okay, so that's coming next. Cyclic molecules, conformational isomers, all that kind of fun in the next video.